Hello Internet! In this video we are going to be taking a look at third-person cameras and how you can actually handle physics with those third-person cameras in a way that's a little bit less janky than if you just use a normal Raycast. Figure coming back, I haven't been making videos for like 10-ish months, I've been focusing on other things, and so we're coming back. We're going to do some more Unity stuff, and this seems like a good place to start. I've laid out a little bit of a scene, but we haven't built anything yet. So what we're going to be mostly looking at is SphereCast's. You might be familiar with Raycast, which is a way to kind of take a laser pointer and shoot it through your scene until it hits something. A SphereCast does the same thing, except it has a radius. And so the advantage of doing something like that is when you go into somewhere like an alleyway or between two objects, your camera won't end up between them and get into this really tiny space or do anything else that can cause it to clip. For example, a camera has a near plane. When rendering, it's kind of hard to see, but when you look at the that's going to be impossible to see. But when you look at the camera frustum of what you're rendering, there's a near plane. And so that near plane for this camera is 0.3, and that things that are in front of that aren't going to render. So if we are using our third-person camera and it is moving too close to objects, we're going to see right through them, and we're actually going to see it's going to look like they're not there. It's going to be weird. So SphereCast give you a way to kind of address that and kind of help deal with that problem. So we're gonna make one. I haven't started. There's nothing here. So typically when I'm making a third-person camera, I do a 2 game object solution, which basically has a single game object as like the origin point. So we'll just call that origin. And then I add a main camera onto that. So I've screwed up everything by doing it this way, but that's okay. So if I do something like this, my camera's gone. Let's get it back. There we go. So our camera's here. I think if we go negative, say 5Z, our camera will end up there. We're actually going to have our camera be dynamically positioned every single frame. And we're going to position it using the SphereCast. And then the origin is going to be what we're actually rotating. So I'm going to attach my third-person camera script to this. If you're wondering what's in there, the answer is nothing. There's nothing there. So that's what we need to do. We need to actually implement this. So let's do that. Let's add a camera speed. I'm mostly focusing on how we can actually handle the camera collisions part of this. Not so much how do we make it really fancy for like smoothly turning and things. Not really what I'm focusing on here. So we're gonna do that real fast, just to make it work. So we're already attached to this origin, so we can just manipulate our current transform to kind of handle this rotation. There's a number of ways to do that. We can actually just multiply the transform.rotation. If we just multiply this rotation by a quaternion this, because we're just doing a 2D thing, we don't need to worry about Gimbal Locking, which is when think about rotation. If you have an X, Y, and Z, think of that as sphere or cones, I guess, circling around one another. If you interlock all of those, it's fine. You can rotate along any of those axes, but because they're interlocked, one is inside of the other, which is inside of the other. What can end up happening is with those rings, gimbal locking is when two of those rings align. So that happens if you have like full 3D movement, like think spaceships. If you're flying around and you flip over and those two axes align, now you can't really rotate in that third dimension anymore because you only have those two, because the one of the 3 dimensions is overlapping the other one. So we don't need to worry about that. We're just going to focus on rotating around the y-axis, so spinning basically in circles. So let's do camera speed times our input. Get axis. I'm gonna make this up because I don't remember how to do this. And there we go. All right, so that's going to rotate our camera. I don't believe we need to scale this by game time. Because we're basing this off of the delta mouse movement. I think if we multiply this by game time, we'd be duplicating that. So this should be everything that we need. If you were using something like the arrow keys, for example, you would want to multiply by the delta time. And so that should be that. If I go and actually run this now, I should be able to spin my camera. That's sort of the goal here, is just to have a camera that spins in place when you move your mouse. This might be backwards. It might be mapped incorrectly. But let's just do this because it'll be a little bit easier to see what's going on. This way we can actually see the scene a little bit. I didn't assign a speed. That's important. So let's say 10. This should be degrees. So this might be quite sensitive. But there we go. As we move our mouse, we rotate. The reason this works, multiplication of quaternions is addition of them. So if you multiply two quaternions, in this case the rotation of our object plus the change in that rotation, we're multiplying those together, so we're getting our rotation plus whatever this new angle is. You can't add them, that doesn't work. So if you're trying to do that and getting an error, multiply them. You can also, there's functions for this too, but multiplication just works. So if that's what you're trying to do, there you go. So everything rotates. Now the next thing I want to do is grab our camera. So let's grab a game object, or let's just grab the transform. We don't need to worry about the camera or the game object. We're just caring about where it's positioned. So we're just going to work with the transform. And this will be our camera transform, I guess. Sure. And so what we're going to do is just say camera transform dot local position. Eventually, this is going to be dynamic. This is going to be assigned dynamically, but we're not doing that now. Instead, we're just going to say vector3 dot back. So negative z, which because our camera is facing forward, we want to go backwards. If we step backwards, the camera will face forward. So we step back, say 10. Our camera should move backwards when we start this. So let's give this a shot. So it's been, oh, that's not gonna work. We haven't assigned a transform, so that's really, yeah, there we go. Broke a bunch of things, cool. So because we're changing the local position of this, even as we rotate this, it should still stay correctly aligned. And then because it's parented, it should pick up that rotation automatically. This is one of the reasons why I like doing it this way, is relying on the game objects to do the complicated math part. And then we can just stick to working in a single axis, and it makes the math easier. So in this case, we're now even further back. And so you can kind of see the error here. That's right there. It's too sensitive. If I move at all, we lose it. But that right-hand side, that right-hand blank spot shouldn't be there. That should be a wall. And now we're inside of one of the walls. We're trying to fix this. That's the goal here, is so that can't happen. So we're going to start with Raycast, and then we're going to move up to a SphereCast. Hopefully the Raycast with this example will show part of the issue. We should still be able to reproduce that issue. I'm also going to tune the speed down a little bit so it's slightly less crazy. Let's cut that by a fifth. Save the scene because I guess I clicked that. Let's see here. My cameras. Sure. All right. Doing weird things. So we have this. What we need to do is make this transform position dynamic. We want this to be something that we can assign every single frame. So what we're going to do is do a raycast. I kind of mentioned this at the start. A raycast takes a laser pointer from a point and shoots a laser basically through your scene until it hits something. And then it's going to return that. Or it's going to have a finite distance that I can travel, so maybe 10 feet or something like that, 10 meters, 10, whatever units you're using. It's going to go that far and then stop if it doesn't hit anything. So you can use this for like hit reg if you're using bullets, for example. You need to see if something's going to impact something. That's a way you can do that. Or you can use it for this, where we're testing, are we going to impact our camera scene or something like that. So the way this works is let's create a ray. new ray with our vector 3 position. So what we're going to do is actually take our current object, so the origin object, and we're going to shoot a ray backwards in the direction that we want to move the camera. So it's going to be this transform position, and the direction is this transform dot back. That's not a thing. Negative forward. All right. So this is a unit vector, so it has a length of 1 in the direction we want to shoot. This doesn't determine the length of the ray. So you don't need to make this some thing, and it's also not the target position. I've seen some people do that in the past. This is the direction it's going. If you do want it to be the target position, you can take the target minus the current position. I believe that's the right way around. It's one or the other, and I always get it mixed up. But that will also work, and then you can just normalize that, and it should all work out. It might normalize it behind the scenes for you, but I'm not sure it does. Anyway, and then what we're going to do is do an if Physics.Raycast. So there's Raycast and Raycast all. Raycast is going to stop at the first thing. It's going to go until it hits an object and then stop. Raycast all is going to go the length of the ray and return everything that was hit in a list back to you. So let's plug in our ray. We're going to do an out hit, which I didn't create. So we're going to have to go and do that. There we go. And we want a max distance, which is going to be our camera distance, I suppose. There we go. Public float camera distance. And that gives us that. And then we want a Raycast hit. So this is going to store the information. It's an output from this Physics.Raycast. So the reason that it works this way is this Physics.Raycast returns a Boolean of if it hits something or not. If it hits something, hit is going to be populated with the information about what was hit. But this gives you, because it's returning a Boolean, it lets you kind of wrap it in an if statement like this, which makes it a little bit nicer to actually write code around this. So inside of this block, hit will be populated and have values, and we can use that to actually reference what we hit. So what we're going to do is just grab that. And I think what we want here is actually just the distance variable. We just want to use the distance because we can just take this same formula and swap out that 10 for the hit distance. Because we moved this far until we hit something, that's the new distance for our camera. Because if you go any further, you're going to be in whatever object, but that should be enough. You could cheat this and subtract like some constant or something, but we don't really need to do that, and it's kind of just trying to get to the SphereCast point without actually doing the sphere casting. So I don't do that. Just use a SphereCast. So that handles it if we hit something, but if there's nothing there, if you have an open world game and your camera's going off into the sky, that 10 unit array isn't usually going to hit much. So we need to handle this case as well. Convenient thing is it should be relatively straightforward. We should just need to multiply this by our camera distance, whatever the maximum value is. And so I can delete this local position up there. And now this is the new updated logic for how we're actually going to assign what we're doing in our scene. So what we should see is this. Because I don't have a full character controller in here, it's a little bit but we can change this camera distance. Let's say let's go with 20. So this should go far beyond my current box scene. That's should be about 10 from any direction, so you'll be able to see it like this. And as we come around here, you can see the camera jumps forward. And then as we move over here, we go inside of a wall, inside of the other wall, and so forth. We do kind of come out there. You can see it's coming a little bit out from the inside of that wall, but we're definitely way inside of this wall. So ideally, we don't want to end up in that little crevice there. In between those two assets or storage crates or whatever, having your camera go behind them so you can't see your character anymore is not ideal. So that's what we're going to solve with SphereCasts, because what we can do is create a sphere that is smaller than that distance. So let's go and do that. My mouse is all over the place. There we go. So let's swap this out. So instead of doing a raycast, we can just swap this for a SphereCast. There's a few other options here. You don't just need to do SphereCast. There's also box casts and capsule casts. So a capsule cast is going to project a capsule through your scene, and a box cast is going to project a box. These can be oriented, for example. So depending on what you're trying to do, those may make more sense. For us, I think a SphereCast, it makes perfect sense. I don't remember the syntax for this, and that isn't the one I'm trying to invoke. But it should be ray, and then I believe the radius. So let's give it one of, say, 0.25. Here we go. And that should be it. That's our SphereCast done. And so we should be able to just see what happens. That isn't a big change, but it should impact pretty significantly what we actually see in our game. So if we start this, hopefully, and actually kind of come around a little bit. There we go. Something like that. And we're actually not even going into that alley at all anymore, because our sphere is colliding with that. We can change that a little bit. It looks like, yeah, maybe it's too small. Let me parameterize this, and then we can play around a little bit just to kind of hopefully make this a little bit clearer. So let's go public float radius, and I'll give this a default just because of 0.25. You can play with this for whatever feels correct. So we want our radius, and we can just that's not right. There we go. So we plug our radius in, and let's do a void on draw gizmos. And let's just add something to draw this capsule or this sphere at wherever it is. So gizmos color equals color dot blue. Sure. And then we'll just do gizmos draw wire sphere. And we want to draw this at camera transform dot position. So the position in world space with a specific radius of radius. And that should at least give us some debug information about what is actually going on. So we have a little bit of a better idea. And there we go. That should be enough. I'm going to move the camera up in my scene view, so we can see, hopefully, what's going on. And also, I feel like I should turn this light down. I feel like it's distracting. There we go. A little better. So if we start this, we should start seeing our sphere in our scene. And I have I can fix this by just turning the camera off. If you didn't know, this gizmos drop down lets you toggle specific things. Let's just turn the camera off. Why? Never mind. It's still there. So not really sure what's going on there. But you can turn gizmos and things off from that menu. So if your scene is super cluttered, you can clean it up a little bit from there. Whatever I did didn't work, so oops. But let's make it bigger, and now we can definitely see what's going on. And let's try rotating a little bit more. So the cool thing is, our position is above that sphere in the corner there, but we're still rotating around it because the bottom of our SphereCast is impacting it. So we're actually going a little bit above it, and it kind of adds this nice smoothing effect around corners as well. So as we get here, There's a bit of a jump there because we're colliding, but then as we actually go over this, you can see it gets somewhat smooth. Kind of hard to tell, but there is some smoothing going on there. We could add some sort of lerp or something, some linear interpolation to actually handle these depth changes. But that's really, I think, a game-specific thing. If you do that wrong, it can make your camera feel floaty, and that's kind of frustrating. But this gives you a way to make a third-person camera that is going to be a little bit nicer inside of your scenery, especially if you have more complicated physics objects and collisions in your scene. This will handle those a lot nicer, and will smooth around them a little bit better than maybe a Raycast would. So yeah, that's that. Hopefully this is interesting and you can use it in your projects. But yeah, I'm back. This is probably the first video I'm recording of a series of them. I've been building a backlog of things to do. So there's plenty of things on my mind. This is one of the simpler projects, but hopefully helpful. If you're interested in cloud stuff or learning about Azure or something, I now work at Microsoft as a cloud advocate. So my job is to help all of you learn things. So I'm actually producing videos similar to this and other content as part of my job for figuring those kind of things out. So if there's information about that you would like to know, and I can help you out there, definitely feel free to reach out. I also do weekly streams over on the Microsoft Developer Twitch, so you can come and check me out there. Other than that, thanks so much for joining me, and hopefully this is the first of many more as we do some fun new things. I've been tinkering with crazy ideas, so I think we're gonna start experimenting. So thanks everyone, and I will see you in the next video. So until then, see you internet.